Hello and good day everyone. So today we're going to continue our tutorial with chapter 4, which is on multivariable function. So let's jump straight into the first question. So the first question, show the following limit does not exist. Limit x, y approach 0, 0 of xy over x squared plus y squared. So this is a multivariable function. It has both x and y as the unknowns. Okay, so question 1, limit, this is what we need to find. This is our function. So we need to show the limit if it does not exist or if it exists. So we need to follow. Let me show you. If you have the textbook, refer to this page, page 114. So these are the cases for you to determine whether the 4 cases to determine whether a limit exists or not if you have multivariable function. Okay, so now case 1. Case 1 is when we let x equal to 0 and we find the limit of y approaching 0. Okay, so limit x equal to 0, y approaching 0 of xy over x squared plus y squared. But now the x is 0, so we replace all x with 0. 0 times y over 0 squared plus y squared. So the limit is 0. Okay, to be safe, you can find the limit of y approaching 0 from the left and from the right, so it will give you the same answer, which is 0. Now case 2, maybe I should write here. Now case 2 will set y equal to 0 and we need to find x approaching 0. We do the same thing. Y equal to 0, x approaching 0, replace all y with 0, x 0, x squared plus 0 squared, and the limit is 0 as well, right? Now two cases are satisfied, they are equal. We look into case 3. Case 3 is when you let x equal to y and you let these two equal to something, let's say t, or you can just use x or y or whatever unknown, but make sure they are all the same in this case. So now we find limit t approaching 0 of we replace all x and y with t. Now t times t over t squared plus t squared. So this is equal to limit t approaching 0 of t squared over 2 t squared. Now don't substitute the limit first because we can simplify, right? So simplify this further. We have limit of t approach 0, we can cancel the t squared, we have 1 over 2. So the answer is 1 over 2. Okay, so case 3 is not equal to case 2 and case 1, so the limit does not exist. Alright, that's it for question 1. Let's proceed with question 2. Question 2 is pretty similar. Okay, question 2. Prove the following limit exists and is equal to 0. And the limit is xy approaching 1, 0 of x minus 1 squared ln x over x minus 1 squared plus y squared. Okay, prove the following limit exists. So we basically need to do the same thing, but it is said that it is exists. So basically all the limits should have the same value. I need to find limit of x, y approaching 1, 0. Alright, so the same. Case 1 is when we let x equal to, but now it's not 0, right? X is 1. Okay, x equal to 1 and y approaching 0. So we will have limit x equal to 1, y approaching 0, and we replace all x with 1. So we will have 1 minus 1 squared ln 1 over 1 minus 1 squared plus y squared. So basically this limit will give you 0. Okay, the same thing, to be safe, you can find the limit of y approaching 0 from the left and from the right. If you have forgotten what I'm saying, please watch the first tutorial video again. I think we solved several questions using that method. So now case 2. Y equal to 0 and x approaching 1. Sorry, y equal to 0, x approaching 1. So we replace all y, only one y here, with 0. Okay, and this will as well give you 0. But now there is one thing about this question that I'm still not sure as well. If any of you know, please let me know. Just WhatsApp in the group or direct message me. Because okay, in the solution given to me, the answer is up to this point, and the answer is the limit exists, which is proven because they are equal, but we don't use case 3 at all. Why? Because you can see that the limit are not approaching the same value, right? So I'm thinking why case 3 is not used for question 2, and in the solution it is shown only up to case 2. So I'll try to find the answer by the next tutorial video. I've forgotten about this. Anyway, if you want to ask your lecturer directly, it's up to you. But and if any of you know, just let me know in WhatsApp, okay? But as far as the solution manual goes, this is the answer, only these two cases, right? Now let us proceed with question 3. Question 3. Find all points where the function is continuous of this function, this given function. So to prove continuity, there are conditions as well. If you have the textbook, refer to page 116. Down here, you can see these are the 3 conditions that a function need to meet in order for it to be continuous, right? So now let's prove. Okay, I'll just rewrite the function. It is multivariable as well. Okay, let's check for the first condition, which states that f x naught y naught is defined, right? So what is your x naught and y naught? Your f x naught and y naught is at x and y equal to 0, 0. So f 0, y 0. Is it defined? Yes, it is defined. And the value is 0. It is straight away given in the function, right? It is defined. If this is 2, then the answer is 2. If it is 3, then 3. But it is defined, right? You have the value, which means it is defined. Now, this is the first rule, which is satisfied. Just put a tick here. Now the second rule is limit xy approaching AB of the function exists. Basically, we need to determine whether this function exists. So we repeat the same method as what we did in the first 2 questions. We look into the 3 cases because it is approaching 0, 0, right? So case 1, real quick, set x equal to 0 and y approaching 0, we will have limit x equal to 0, y approaching 0, replace all the x's with 0, and we'll have 0 squared y over 0 squared plus y squared, and the limit is equal to 0. Now case 2, we set y equal to 0 and we find the limit of x approaching 0. So limit y equal to 0, x approaching 0, we replace all the y's with 0, we will have x squared 0 over x squared plus 0. Similarly, it is 0. Now we can look into case 3. We set x equal to y equal to t, right? So limit 3 approaching 0 of, we replace all the x and y's with t, we will have t cubed over 2 t squared, simplify, limit t approaching 0 of t over 2, so it is 0 as well. So the limit exists. So the second rule is also satisfied, and the final rule, which is limit xy approaching AB of fxy is equal to fab. So rule 3 states that let's see, if limit xy approaching 0 0 of x squared y over x squared plus y squared is equal to fx naught y naught. Okay, so this is, what is the limit? It is 0, right? Because we have found the answer here, the limit is 0. So this is 0, and f 0 0 is also 0, so they are equal, means let me just rewrite again. Just to make you see it clearer. So this is the third rule. So all rules are satisfied. Okay, so this means that the function is continuous everywhere. Right, so this is your final answer for question 3. Okay, now let's proceed with question 4. Determine where fxy equal to ln x plus y is continuous. Right? This is pretty simple. So fxy equal to ln x plus y. So for this to be continuous, let me check first if I'm not mistaken. Okay, it's correct. So a ln, we cannot ln value that is 0 or value 0 or less than 0. We cannot get the answer for ln 0, ln negative 1, ln negative 2. We can only start finding the answer from ln 1, ln 2, ln 3 and so on. So to find to make this continuous, x plus y must be more than 0, not more or equal, it must be more than 0. So x must be more than negative y. So basically this is the answer. X must be more than negative y for this function to be continuous. Right? That's it for question 4. Okay, since the textbook only have 4 questions and we're only 20 minutes into the video, if I'm not mistaken, so I'll give you 2 extra questions which I think is quite famous, but I'm not sure whatsoever about your final exam question. This is just what some of the famous questions back in my degree days. So I'll put it as question 5. Actually this is from Dr. Loh's workbook, so you can refer to that book. So the question is, sketch the level curve of z equal to k for the specified values of k. So there are two parts. Part 1 is z equal to x squared plus y squared for k equal to 0, 1, 2, 3, 4. Actually there are several ways on how you can solve this. The easiest way is if you know what shape is this function. So if we replace z with constant, this will be two-dimensional, right? Two-dimensional on xy axis. So this is basically a circle equation, right? This is a circle equation with radius of square root of z, right? So you can just straight away draw it. The drawing should looks like, I'll draw first. Let me just show you the drawing. So it is two-dimensional xy axis, since z is replaced with constants. So at z equal k, okay, alright, don't forget about this. So basically this is k. So when z equal to 0, the radius is 0, so it is just a point, alright. When z equal to 1, the radius is square root of 1, which is 1, right? Let's say this is 1, the radius is 1, everything is 1, negative 1, 1, 1, negative 1, right? When the radius is 2, z is equal to 2, the radius is set of 2, so square root of 2 is 1.41. So 1.41, let's say here, 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 and here, right? So when it is equal to 3, the radius is 1.73. Let's say here, 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 and here. When it is 4, it is 2, right? 2. The radius is 2. So basically this is the drawing. Okay. Another way, you can also do like this. If you can plug in every value into the equation, you can solve this like this as well. So first you let x equal to 0, and you make two columns of k and y. X equal to 0 and the unknown is y. So z is equal to 0, 1, 2, 3, 4. So you plug in k here. What is the value of y? It will be 0, 1, 1.41, 1.732. And next, the second table is when y equal to 0. Okay, this is x now. So the same thing, you'll have the same value as well. So if you plot this at k equal to 0, y equal to 0, 0, k equal to 1, y equal to 1, 1. So it will look like this as well, right? This is another way. You can use this method only if you have only if you can plug in all the given value of k into the function. Right, now let's try again question 5 but with different equation. Part 2, question 5. The function now is changed to z equal to x squared plus y, and z is equal to k, remember, and the k is equal to -2, -1, 0, 1, 2, right? But now I just use the quicker way, like the first method I showed you in the previous part of question 5. So now when you look at this, how to put this, let's do it this way. Let's say we let the first case, we let x equal to 0, so z will be equal to y. So basically y equal to k, right? Because z is equal to k. And case 2 is we let y equal to 0, we will have z equal to x squared or k equal to x squared, so x is equal to set of k. Should we do it this way? No, I think this way is harder. I think we just look into this equation straight away. Okay, so what equation is this? If you can see, this is a constant, right? Let's say k, so k equal to x squared plus y is basically quadratic function, right, of x squared, but we shift it by y, right? So if it is negative, we shift it downwards. If it is positive, we shift it upwards. So let's draw. First, remember, what is the function of x squared? K equal to x squared looks like what? K equal to x squared looks like, k equal to x squared looks like this, right? Right? K equal to x squared. So we will shift this upwards and downwards based on this. So at k equal to, we'll start at 2 right here. K equal to 2. Let's see. It will be shifted upwards by 2 point because k equals oh sorry, I think we will need these equations, so I'll just write it again. At x equal to 0, y equal to k, at y equal to 0, x equal to set of k. So at k equal to 2, y will it be equal to 2, and x will be equal to plus minus square root of 2, right? Because this is set, it must be plus minus, right? Set of 2, so plus minus 1.41. Okay, so maybe let's say this is 1.41, this is negative 1.41. So this is the point, this is the point, and y is equal to k, k is equal to 2, this is the point, and the shape should be like this, right? So it will be something like this. Okay, Now when k equal to 1, y equal to plus minus 1, see here and here, and this is plus minus 1 as well, plus minus of square root of 1, so plus minus 1. So let's say 1 is here, so it will look like this. So the same for the other values, you can try. And this is not accurate drawing, so it should be something like, I mean not accurate on the basis of the intersection points, okay, but the shape is correct, right? So it will look something like this, okay. Now I'll show you another question, another example from Dr. Lo's workbook as well. Before question 5, we drew two-dimensional function. Now we'll try three-dimensional function. Question 6, the question is, sketch the graph of f x y equal to 4 minus x squared minus y squared. Usually I would like to refer f x y as z to make our solution easier. Alright, so how to draw this? I'm not sure on the methods your lecturer taught you, but as for me, normally I will make it like this. I will let each of these unknowns as 0 and find the points manually, or just look at the shape of the function if you know the function. So let's start first with z equal to 0. So at z equal to 0, we have 0 equal to 4 minus x squared minus y squared. If you rearrange this, you will have x squared plus y squared equal to 0. Equal to 4. So basically this is a circle with radius 4, right? So let's accept this first. We'll look at x equal to 0. When x equal to 0, z equal to 4 minus y squared, right? So this looks somewhat like our previous function from question 5 part 2, right? Now x equal to y equal to 0, we will have somewhat like this as well. Z equal to 4. It is basically the same as this, right? So what you're going to do is you repeat the steps as what we did here, but 3 times. First, for this, y axis is on the xy axis. So at z equal to 0 again, the drawing is on the xy axis. Okay, so it is a circle with radius of square root of 4. So the radius is 2. So basically it is like this, right? Now at x equal to 0, we have z minus a equal to 4 minus y squared. What plane is this on? It is on the zy plane. So It must be on the Z, Y plane. Alright. So the shape, if you repeat from what we did here, you will have the drawing like this. This is 2, -2, 4. Now at y equal to 0, we'll have the same drawing as this, but on the, let me rewrite the function. No, yes, this is the function is, so it is on the zx plane, but not this one was in zy plane, but now it is on zx plane, but the shape is exactly the same, but now it is zx plane. Exactly the same shape. Okay, so now we draw our 3D plane for the final drawing. You can name the plane however you like. I'll name it as X here, Y, Z. So look at, so we need to redraw this, all of this. On this 3D plane. So we'll look at this one first. So this is on ZX plane. So you just focus on the Z and X plane, which is there. From here to this. Don't care about the Y plane. You need to imagine it to be two-dimensional from of the ZX plane. Imagine this plane is rotated. This plane is rotated here. Alright. This plane, you take this plane, you rotate it on the 3D model here. So you will have something like that. Now you take the ZY plane here, exactly here. So you'll have something like this. Okay. Now this XY plane here, right? You put it on the XY plane, which is on the horizontal line, right? So it is like this. It is hard if you cannot imagine this. So basically the shape is like a cylinder, right? But this goes down to infinity because this 2 goes to infinity, and the shape is a curl. It is a curl here, it is a curl everywhere, right? I hope you can see this. But this basically is like a cylinder, like the top of this pen. Okay, and this is 4, and all the sides are 2, 2, 2, 2, like this, right? Okay, can you see it? Please practice so that you can imagine. You need good imagination for this. Another way, you can plug in values manually here. For example, but you get the same thing. For example, you plug in at x equal to 0, y equal to y, and you take, you say, I'll just show you randomly. let's say at z is equal to 0. So at all times z is equal to 0, which is on this plane at the 0 axis here. So then you plug in at x equal to 0. When x equal to 0, at z equal to 0, what is the value of y? You plot, so you get 2, for example, and negative 2 at a different value of x. You just need to do trial and error. So now you look at this at x equal to 0, and when z is equal to at x equal to 0, and when y is equal to 0, what is the value of z? You point. So after you have point everything, you have the basic shape, you plug in the value as well as, and you might get the idea of how the shape would look like. Okay, this is another way, but a longer one. This is useful if you are not aware of how the function would look like, how to plot the function, because this is obvious, a circle, this is a square root, and not square root, squared function, which should look, if it is negative it is like this, if it is positive it is like this. But if it is some random equations, you need to do manually by substituting test values. Alright, I think that's it for this tutorial. We'll meet again in the next tutorial, and hopefully I can find the answer for my questions regarding this tutorial's question 2. Okay, regarding the case 3. If any of you have the answer, let me know. See you. Thank you.